Have you ever wondered what dwarf planets are and why they are called so? Let's dive into the cosmic ocean and shed some light on these celestial mysteries. Dwarf planets are bodies orbiting the sun that are too small to be classified as regular planets, but too big to be considered asteroids. They're called dwarf, not because they're insignificant, but because they lack the gravitational pull to clear their orbit of other debris. But don't let the dwarf tag fool you. These miniature marvels are just as fascinating as their larger counterparts in our solar system. From the icy plains of Pluto to the mysterious Eris, dwarf planets provide us with a wealth of knowledge about the universe we inhabit. They are the unsung heroes of our cosmic neighborhood, often overshadowed by their larger siblings, yet filled with their own unique tales of cosmic evolution. Dwarf planets, though smaller in size, hold a universe of information waiting to be explored. But what makes a celestial body a dwarf planet? What are their unique characteristics? Let's dive into the fascinating world of these space underdogs. First and foremost, to be classified as a dwarf planet, a celestial body must orbit the sun. This might seem like a given, but it's an important criterion nonetheless. It sets dwarf planets apart from natural satellites like our own moon, that orbit planets instead. Now, where things get a bit more nuanced is that, unlike the 8 planets in our solar system, dwarf planets haven't cleared the neighborhood around their orbit. What does that mean, you ask? Well, in simple terms, it means they share their orbital highway with other celestial bodies, like asteroids, comets, and sometimes even other dwarf planets. They just haven't asserted their gravitational dominance to clear out their path entirely. Thirdly, and this is my personal favorite, a dwarf planet must be large enough for its gravity to shape it into a sphere. This rule is all about the battle between structural strength and gravity. When a celestial body is small, its structural strength keeps it rigid, often resulting in irregular shapes. But as a celestial body grows larger, gravity begins to take over, pulling inward and shaping the body into a sphere. This is why dwarf planets like Pluto, Eris and Haumea, despite their smaller sizes, share the same spherical shape as their larger cousins like Earth and Jupiter. And speaking of Pluto, Eris and Haumea, these are some of the most well-known dwarf planets. They each have their unique attributes and mysteries, adding richness to the tapestry of our solar system. For instance, Pluto, once considered the 9th planet, has a heart-shaped glacier that's the size of Texas and Oklahoma combined. Eris, the second largest known dwarf planet, is so far away from the sun that a single year there lasts over 500 Earth years. And Haumea, with its odd elongated shape, spins so fast that a day lasts less than 4 Earth hours. So, while they may not be as dominant as the planets of our solar system, dwarf planets have their unique features that set them apart. Now that we know what dwarf planets are and their characteristics, let's delve into their classification. Dwarf planets are primarily classified based on their location in the solar system. Those found in the asteroid belt, like Ceres, are termed asteroid belt dwarfs. Beyond Neptune's orbit, in the icy realm of the Kuiper belt, dwell Kuiper belt dwarfs, the most famous of which is Pluto. These classifications aren't just labels, they offer us a way to understand the formation and evolution of our solar system. Studying dwarf planets in the asteroid belt, for instance, provides us a glimpse into the materials that built the inner planets. On the other hand, the Kuiper belt dwarfs, being so far from the sun, have remained relatively unchanged since the solar system's infancy. They serve as frozen time capsules preserving the early conditions of the solar system. The study of dwarf planets, thus, holds the potential to unlock secrets of our cosmic neighborhood. In conclusion, dwarf planets are more than just smaller versions of planets. They are intriguing celestial bodies, each with their unique characteristics and mysteries. Dwarf planets, identified by their inability to clear their orbit yet maintaining a spherical shape, are an essential part of our solar system and beyond. Their diverse composition, ranging from rock to ice, provides a rich field for scientific inquiry. We've discussed the known categories, including the famous Pluto, the icy Eris, and the intriguing Ceres nestled within our asteroid belt. However, it's important to remember that our understanding of these bodies continues to evolve. Studying dwarf planets offers us the chance to delve deeper into the mysteries of the universe, to understand better the dynamics of our solar system, and perhaps even to unlock secrets about the origins of life. As we continue to explore the cosmos, who knows what fascinating discoveries await in the realm of these dwarf planets?